Welcome to Maths with EJD. In this video, our focus is on union and intersection of sets. So let's start with union of sets, of sets, union of sets. A union is like a marriage, right? And it's also useful here. And in a marriage, when two people get married, a man and a woman get married, right? And then you they bring all their assets and their liabilities together, right? So that is union. That is what union of sets is about. Okay. So let's go. The union, the union of two sets, the union of two sets A and B is a set containing containing all the elements of A, B, or both. So any element that appears in A or in B or in both is part of the union, right? So it is denoted, it is denoted as A union B, A union B, and that means A union B is equal to is the set of all X such that X belongs to A or X belongs to B. So once X belongs to either A or B or both, then it is part of the union. So let's take examples. So we have 1. A is 1, 2, 3. B is 3, 4, 5. Okay, so A union B now would simply be 1, 2, 3, 1, 2, 3, union 3, 4, 5. Union 3, 4, 5. That simply means once 1 is in A, you pick it. 2 is in A, you pick it. 3 is in both, you pick it. 4 is in B, you pick it. 5 is in B, you pick it. So the union of A and B is everything they have in common and everything each person has. So that is the idea of union. So for another example, talking about fruits now, A, if A is apple and banana, apple, banana, and B is banana and orange, banana and orange. Okay. So A union B is simply apple is in A, you have apple here too. Then banana is in both, you have banana. And orange is in B only, so you pick it. And that is your A union B. So I'd like to give a third example. Let's say in a third example, P is what do I do now? Okay. Um, let me think. Okay, let me just take something simple. So we say ball, bed, and and broom. Let me just use that. And then uh Q is table, chair, table, chair, and say stool. Okay. So P union Q is equal to, now you can see they have nothing in common, but then their union will be everything everybody has. Just put them together. So you have ball, bed, broom, table, chair, stool. Even when they don't have anything in common, you just put everything they have together. If they have something in common, you pick one of that because repetition is not allowed in sets. Or even if there's repetition, it is ignored when you're reckoning with the set. So let's talk about application, application of union of sets. Where can we apply this? I've told you you can apply it in marriage, right? All right. So we know that we can also see the use in Venn diagram. In Venn diagram, in Venn diagram, the union of two sets, the union of two sets represents the area, the area, the area covered by both circles, which could which could be used to analyze, which could be used to analyze survey results, survey results like the total number, like the total number of people of people who like either or both of two products, both of two products. So when we get to Venn diagrams, I'll explain comprehensively what this is like. Okay, so we move on to talk about the union operation properties. Union operation properties. Union operation properties. So union operation properties. The first property of union is commutativity. Commutativity. That is A union B is equal to B union A. It doesn't matter which set comes first. Their union will always be the same. Okay? Then, because of course, the order of a set, the order of elements in a set does not matter. Then you have associativity. Associativity. So that means that A union B union C is the same as A union B union C. So if you have three sets and you take the union of the last two first before taking the union of that whatever you get there with the first one, it's the same thing as when you take the union of the first two before taking its union with with that of C, So that's associativity. And of course we have identity. Identity is this A, the union of A and the empty set is always A. So it's more like you're adding 0 to a number. So you get that number always. Then you have idempotency. Idempotency. I taught matrices in the past, and the idea of idempotency came up. So that might have a bit of resemblance with this. So for idempotency, the union of A with itself is always A. So if you put two exactly same people together, they just bring the same set of skills. They bring the same set of exposures and everything. That's idempotency. Okay, so that's all about union of sets. That's all about union of sets. Now let's go to the intersection of sets. Intersection of sets. As the word implies, you can already see the idea of intersection. It's more like two things meet. Wherever they meet, that's the intersection. Intersection of sets. Intersection of sets. So the intersection of two sets, intersection of two sets, A and B, is a set containing only the elements that are in both A and B. So the intersection of two sets is the list of only the elements that are common to both A and B. And it is denoted as A intersection B, something like N that way. So, and in a more formal way, A intersection B is the same thing as X, the collection of all X such that X belongs to A and X belongs to B. For the sake of, in the case of union, this was all. So X so for union, right, belongs to A or X belongs to B. Once it belongs to either of the two, then it is part of the union. But for intersection, it must belong to both A and B. So, and that takes us to the examples. So if you have A to be 1, 2, 3, and you have B to be 3, 4, 5, of course, A intersection B is going to be 1, 2, 3, intersection 3, 4, 5. In that case, only what is common is what you're going to pick. So you see 3 is here and 3 is here. So the result is going to be only that 3. So that means the intersection of A and B is the set of only 3. It's a singleton set of with only element 3. Okay. So number 2, we have a set A, which is a collection of cat and dog, and you have a set B, which is a collection of dog, cat, and bed. Dog, cat, and bed. Of course, A intersection B is going to be what is common to both. So cat and dog are common to both sets. So of course, B has something extra, which is bed, but the intersection only cares about what is common. So you have cat, dog, and that's it. So those are the examples. So can we talk about the application now? Application of set intersection. Application of set intersection. All right. Database queries, in database queries, intersection can be used, intersection can be used to find common records, common records, common records between two datasets, between two datasets, between two datasets, like like finding customers, customers who bought both products A and product B and product B. Or if you're an HR, probably you send birthday messages to people on their birthdays. So one thing intersection can do for you is you want to find everybody whose birthday is on the same day. So you can just query that and it will give you the list and then you send them a message, right? So let's talk about intersection operation properties. Intersection operation properties. Of course, what we've been talking about, complement, difference, union, intersection, they are all set operations. They are all set operations. So set intersection operation properties now. Intersection operation properties. Intersection operation properties. Say the first one is commutativity. Okay. So commutativity, you remember union is also commutative. Intersection is commutative. So commutativity is that A intersection B is the same thing as B intersection A. So whichever comes first, it doesn't matter. What they have in common is still the same. Then it is intersection is also associative. So you have associativity. That means the order in which you find the intersection of 2 of 3 sets doesn't matter because A intersection B intersection C, B and C in brackets is exactly the same as A intersection B first and then intersection C. Okay, that is associativity. And then you have identity. Identity. So identity, that means A intersection the universal set is equal to A itself. This is the universal set. A intersection the universal set is A. That is the only thing that is common to A and the universal set is A itself, because A is always a subset of the universal set. And then there's also the idea of idempotency here. Idempotency. Idempotency. That means the intersection of A with itself is A. All right? The intersection of A with itself is A. So that is that about intersection of sets also. So with that, I can say we have come to the end of this video. But then as usual, let's take some practice questions. Practice questions. Okay. Um, let's see this. Say again, you have the okay, universal set is not necessary here, right? Because we're talking about union and intersection. So let's take this following. Given set F to be um L M N P Q, and okay, that's F, right? And G is L N Q. Okay. H is M P. I is L M P. Okay, let's stop there. Find the following. Find the following. 1. F union G. 2. Okay, let me go this way. 1. F union G. 2. F union H. 3. F union I. 4. G union H. 5. This is going to be a lot, so get ready. G union H. G union I. 6. H G union I, right? Next is H union I. Then, so do the same again all over. So then we have 7 F intersection G, 8 F intersection H, 9 F intersection I, 10 F intersection now G intersection H, G intersection H, then 11 G intersection I, then 12 G intersection H intersection I, H intersection I. Okay, just try your hands on this. Very simple stuff. So with that, we've come to the end of this video. So if you have not subscribed, be sure to do that. Hit the notification bell also, so you can always get alerted each time a new video is released. Don't forget to comment, talk about what you need clarification on, or if you have a question to ask, or if you won't do this research, the practice questions, you can also, upload your work in the comment section. Of course, be sure to like and share also, so that more people can have access to this pool of knowledge. Thank you so much for always stopping by. See you in the next one. Bye.